Stephen and Andrew are an engineer and a development manager in a medium-sized company. While the complexity, cost pressures, and the number of products in their portfolio continue to rise, the development time is getting shorter and shorter. Because their customers and suppliers are working with different CAD systems, their data has to be expensively adapted for the in-house 3D CAD program, and changes have to be implemented manually. In addition, adjustments to the models are often necessary very late in the development process. All these factors annoy the team as they increase time pressure unnecessarily. When the two then consider what causes these problems, they notice that their CAD system is really only used to draw in 3D, while a modern solution could do so much more. They could simply use their partners and suppliers' data as it is, rather than converting it, which is very time-consuming. They would save a lot of time if they could evaluate different design approaches in parallel and in a more structured way. Until now, they've had to produce countless versions, which quickly became confusing. In addition, the present system restricts the designers because in some applications, they would rather not use parametric modeling. But the current CAD system does not allow this. If the two functions could be combined, they could not only finish more quickly, but would also be much more flexible if a customer requests changes to almost finished parts. Currently, different programs are used for design, calculation, and simulation. This difference in format costs time, and the data which, for example, serves as a basis for the simulations are not automatically updated when changes are implemented. An ideal system, however, will let you consistently reproduce all steps from design to manufacturing. All information such as calculations, tolerances, etc. could then be integrated directly into the model. This way, all departments and organizations involved in the process could use this data consistently and simultaneously, which would greatly facilitate communication and reduce effort. Since kinematics and collisions could be investigated on the digital prototype, errors that are currently only noticed during the building of the prototype would be found earlier and could be avoided. Both Stephen and Andrew see further potential for optimization in manufacturing. Currently, designers are working in 3D, but manufacturing is carried out on 2D drawings. Time creating and updating the 2D drawings could also be saved if the NC programs were generated directly from the 3D model. When Stephen and Andrew discuss these opportunities with their boss, they get even more ideas, because in addition to the engineering department, other departments could benefit as well. With a universal system, they could start to develop smart connected products, and new manufacturing processes, such as 3D printing, could be used in a better way. Sales, marketing, and service could work faster, because the images and graphics that are currently created only at the end of production could be replaced with 3D renderings and visualizations and be generated parallel to design. Not to mention the use of augmented reality in service, sales, and training, which they expect to bring significant advantages. In order to implement their wishes as quickly and smoothly as possible, Stephen and his boss have opted to use Creo software with INNEO as the implementation partner. Creo provides them with all the features they need to implement their new ideas and methods, and thanks to over 30 years of experience and over 4,000 customers, INNEO offers the necessary expertise for the project. And what about you? Learn about the advantages of Creo now.